This is the fossil of a trilobite. It's an animal that lived in shallow ocean waters, somewhat similar to the horseshoe crabs that we still see in oceans today. But this fossil was found in Morocco, hundreds of kilometers away from the nearest ocean. How did the remains of an ocean-dwelling animal end up in the desert near the top of a mountain? The answer is time. Lots of time. I'm Science Mom.
And I'm Math Dad.
The fossils and rocks on Earth offer clues about what life was like thousands and millions of years ago. Today, we're going to look at some of the highlights of the geologic history of our planet. The age of insects, when millipedes longer than a person roamed the forests, the age of dinosaurs, and the extinction event that separates the two. Good morning or afternoon if you are watching in the UK, Africa, or Italy. Hello to Sonica watching in Oregon, to Olivia in Minnesota, Mindful Mission, Caitlin in California, Ibrahim in Canada, Amaya in the UK. Welcome! Today we are talking a bit about geologic time.
Geologic time, that's going to be thinking about going way back in history, right?
Way back in history. And I'm curious if anybody has a favorite prehistoric animal. In the little introduction, I shared this fossil of a trilobite. Trilobites are fascinating, really cool animals that used to be one of the most numerous animals on Earth. There were so many different species of trilobites. Some of them were big, like this one, and others were a lot smaller. And some of them had really cool kind of they almost looked like horns, kind of antenna things. Does anyone have a favorite prehistoric animal?
Did those live in the ocean?
They did live in the ocean. They were marine animals. They did not live on land. And they had little shells that kept them safe from predators, and they lived in shallow waters. Math Dad, take a look at our chat. Let me know if we have any favorite prehistoric animals that are coming in.
Anders says cockroach. So those are prehistoric. They go way back, right?
They do go way back. They've been around for a long time. And I'm seeing pterodactyls. Those are a great animal. Megalodons, the enormous sharks that were prehistoric.
Harper said T-Rex.
Ammonites. And Tatiana said ammonite. I have an ammonite fossil right here. This is a fossil that was around at the same time as the trilobites, an animal that lived in prehistoric ocean waters. Super numerous. There were so many different types of ammonites. They were really abundant, but we don't see them in oceans today.
I'm seeing Denali like saber-toothed cats.
Saber-toothed.
Eva as well, yeah.
Saber-toothed cats are a great one, and more recent too. We don't have to go back quite as far in time to find those.
I'm seeing several dinosaurs listed, like Ankylosaur or a T-Rex or a Triceratops.
T-Rex and Triceratops are great ones. I like Ankylosaurs as well, and I have a model of a T-Rex claw right here. This is not a real claw, but can you imagine an animal so big that basically like its first fingernail? Because Paladin, science puppy here, he has claws too. We call them nails, but tiny little, he's like, no, are you going to clip my nails? Don't do it. This T-Rex claw is enormous because the Tyrannosaurus Rex was a really big dinosaur.
He needs really large nail clippers.
Yes, you would. If you wanted to clip T-Rex's nails, they would have to be really big.
Kind of short little arms too. Kind of funny.
Now, have you ever wondered why were some of these animals that we have fossils for, like the T-Rex or the trilobite or the ammonite, why were they around a long time ago, but they're not around now?
Well, they're extinct, right?
The answer is extinction events.
Or they're hiding really well.
They're not hiding really well. They went extinct. And the story of how and why certain animals went extinct is really a fascinating one. Let's start by looking at trilobites. And we're still seeing really great suggestions and animals in the chat for favorite prehistoric animals. Love all these. All right, trilobites lived. Are you okay, Matt?
Oh, I think I have the wrong camera source.
Oh no, we have the wrong camera source. We'll fix it really fast, you guys. There we go. Trilobites lived a long, long time ago, and we'll talk just a little bit about our geological time period in a minute, but right around the time of the Carboniferous, they started to decline, where we see fewer and fewer trilobite fossils. And instead, when we get into the Carboniferous, and this is one of my favorite time periods, so we're going to pause here and talk a little bit about what the Carboniferous was like. We have different animals. On land, we had incredible rainforests, but these rainforests did not have any flowers.
Wait.
There were no flowering plants.
How could there be no flowers?
There were no grasses. There were no flowers. There were no trees that had flowers. This was a different time.
Whoa.
And the plants were ferns. You had ferns which had reproduced with spores instead of flowers and seeds, and you had cone-bearing plants like these lycopods, these huge trees that had cones, but they did not produce flowers. And in this prehistoric jungle that had enormous rainforest-type plants, but no flowers, you had enormous insects. One of my favorites is this one, Anomalocaris. It was an enormous millipede that was so long, if you laid down, it would be taller or longer than you.
Whoa.
But it was a vegetarian. It only ate plants. So if you ran into one, you would not miss it.
I think that would still scare the gajebers out of me.
Yeah, you wouldn't need to be afraid of it. There were also giant amphibians and insects in these forests living on land. The giant dragonfly, and let's kind of show with our hands, Matt's Ed, how long is a meter?
Ooh.
So
just over 3 feet, so about as wide as I can hold my hands in the camera shot here.
So do you see that amphibian there that looks kind of like a lizard? That's how big that amphibian would have been. And Meganeura, the giant dragonfly, was not that much smaller from wingtip to wingtip.
Oh, man.
75 centimeters?
Yeah, about that long.
Yeah. So next time you see a really big crow that spreads its wings out, imagine a dragonfly that big. And then if you were scared of the giant millipede, Math Dad, I have bad news for you because there were giant pseudoscorpions.
Oh, my goodness.
That were this big.
Yeah, okay. I would see how fast I could run because I'm just not risking it. That's just scary.
And they were not herbivores. They were not only eating plants. So those you might want to steer clear of. In the ocean, there was also a lot of life in the ocean during the Carboniferous, and the ocean life, some of it was just as bizarre.
Whoa.
One of my favorites is Stephacanthus. This prehistoric fish, and this was not, it looks like a shark and it is kind of a shark-like fish, but they weren't really big. They were maybe about 2.5 to 3 feet long at most, but they had this strange growth on their back, this hump here, and we don't know why. There are a couple theories about what it could have been used for, but really, we have no idea. Why did it have that growth with sort of these little filaments on the top coming out of its back? We don't know.
Yeah, that's really weird. Okay, and what is this thing?
This is a nautilus. Whoops, and it looks like I started typing nautilus and stopped in my slides.
Okay.
There were lots of different species of nautilus. Some of them had shells that curved all the way around in a spiral, and others were more straight. There's a fossil of a nautilus. And this is one of the few animals from the Carboniferous period that survived the mass extinctions that followed. And we actually still have some of this type of animal in our oceans today.
How do those even move around?
They actually have air sacs inside the shell that they can kind of inflate and deflate to go up and down.
That's pretty cool.
Pretty cool, right?
Yeah.
Now, when we're talking about geological time, it's kind of hard to just picture how long it is. I want to point out 2 things real quick, and then Math Dad made a fun little exercise. So we have eras, and those are longer than periods or ages. So when I say that an era is longer, I mean, think of it like a year is longer than a month, right? Years contain multiple months. An era is like a year, and a period is like a month. But we're talking way, way longer. So you've probably heard of the Jurassic period, like in Jurassic Park.
Yes.
Or the Triassic. This is like the age of dinosaurs. The age of dinosaur, these 3 periods, Jurassic, Triassic, and Cretaceous, those all took place in the Mesozoic era.
Gotcha. Now, they're not all equal size, but this is just a good way of comparing it. Like years are longer than months, which are longer than days.
So let's talk about just how long this is. So we made a little piece of paper here that is about 1 millimeter in length. That little blue line you can see is really thin, And if you have 365 of those and put them all together, then you get this purple length. So if a millimeter is a day, then this is a year.
So I like to think of this as a time. What if we had a time machine where as we walk along, we can walk back in time, and that's 1 year. So we could walk back. Sorry. This whole thing is 1 year.
Is 1 year.
Each of these is 1 day.
So what if you could walk back in time, where you're standing right now? If you took a step this far, that would be 1 year ago. And if you took 2 of these, that would be 2 years back. So what I want to know, and I want you to guess, if you're watching live right now, put it in the chat and guess, how far would you need to walk to go back 50 years?
Ooh,
so this is going back 1 year, this little blue line here.
That's 1 day.
1 day. And this, if you step this far, you go back 1 year. How far would you need to walk to go back 50 years? And you can take a guess in steps, or you can tell us in inches, feet. Math Dad gave the answer already.
There's the answer, Boo.
60 feet or 18 meters.
So about as wide as a house. Like that. Yeah. That's quite a while. So 50 steps.
Yeah. Kian guessed 50 steps. 50 steps is a good guess. It would be about that. Of course, it all depends on how big your steps are. What about going back even farther? What about going back to the age of the dinosaurs?
Ooh. Well, just before we get to the dinosaurs, I've got one more. The pyramids. When the pyramids were built, how far would you have to walk in your walking time machine?
Just over a mile, or 1.6 kilometers.
So that would be to get back to the ancient pyramids. All right.
Okay, how about the dinosaurs? And I want to wait and see if anyone has a guess in the chat before we reveal the answers. How far? And if you're watching the replay, just take a guess and say it out loud. How far do you think you'd have to walk to get back to the dinosaurs? If you were a walking time traveler and every time you took a step this big, it took you back 1 year.
It's kind of an interesting question, because 1 millimeter is so small that just by wiggling my head here, I'm going back and forth decades. Oh, there was my whole life right there. It's bobbing my head. 60 million feet, 20 miles, 500 feet, 65 million. No, 65 million years is how far we'd have to go back to get to the dinosaurs. That is true.
So that's a long distance.
All right. And, I even hadn't, to get to the dinosaurs, you'd almost have to do a trip around the entire world.
Whoa, that is crazy. So far.
Just to get back to where the dinosaurs went extinct. One whole trip around the world, even though these are such baby steps, that tells you how big this timeline needs to be if we wanted to really plot it out. I did have one other, the full ice age. So we said right now we're in an ice age, but it's an interglacial period. So we're not at the peak of an ice age.
Yeah, so the last glacial maximum
was 22,000 years. So then you'd have to go about 8 kilometers or 5 miles to get to that. All right.
This is 24,000 miles. So 24,000 miles, that's a long, long time. I knew someone who kept track every day when they went running. They kept track of how many miles they ran, because their goal was in their lifetime to run the equivalent of the distance around the Earth, to run 24,000 miles. And it took them decades.
Wow.
Decades to do it.
All right. And then let's see if we can go back even further to the age of the Earth. So the Earth is 4.5 billion years old. And there would be 26 trips around the world going back where 1 day is 1 millimeter. That's a long time. And those numbers are so big that we're just not good at wrapping our heads around it, because it's bigger than anything we encounter on a day-by-day basis.
It's hard to picture.
I'm a mathematician, and even I start getting cross-eyed when the numbers get that big and trying to imagine the sheer scope of this timeline. So geologists, they really have to change the way they think about the world. And kind of like when we think about plants, like they've got their whole, they're slow, they don't move, but they actually do move. They experience things, but it's just on a much slower time scale. Well, geological time is way slower.
Way slower. So think about this, this trilobite, which was found in Morocco in Africa. This fossil is now made completely out of rock. And we'll talk more about how fossils form this next week. But this animal, this fossil represents, the shape of it is from an actual living animal that lived in shallow oceans. But over time, lots and lots of time. It got buried in mud, and then that mud got turned into rock, and then that rock was pushed up into a dry desert where it was found near the top of a mountain. It's amazing, isn't it?
Wait, over time. So that's
Time.
Not something that happens in just 5 years or 10 years
or even 1,000 years. This takes hundreds of thousands or millions of years to happen. Now let's talk a little bit about extinction events.
Is this a real fossil that they're asking in the chat?
Yes, this is a real fossil that a friend of mine who's a geologist lent to me. Cool. Now let's talk a little bit about extinction events, because that's what separates these eras. Why do we talk about there being a Mesozoic era and then after that there's a Cenozoic era? And it's because of extinction events that separate them. So when you're looking at the fossils, and there are ammonite fossils everywhere, and the rocks are getting younger and younger, and there still are different types of rocks, but you still see these fossils, and then all of a sudden these fossils disappear. It's like, oh, it's a different time now. Conditions are different because we don't see these fossils anymore. There have been 5 major extinction events throughout Earth's history. And here in this graph here, we're going from oldest to youngest. And if you look at just how many species disappeared from the fossil record, there are 5 main big ones: here, here, and here. And this one right here, between the Permian and the Triassic, they call it sometimes the TP extinction event or the Great Dying. We're going to talk about that one just a bit because it is the biggest one.
So lots of things died. What happened?
Oh, so 90% of the animals that live in the ocean disappeared.
Oh, man.
And the reason they disappeared is because the ocean got warmer. And when the ocean got warmer, oxygen gas couldn't be in the water as well. Cold water holds more oxygen than warm water. So there were a couple different things that happened. The oceans got warmer. There was more carbon dioxide in the atmosphere and more methane in the atmosphere, and that caused the oceans to warm. The pH of the oceans changed a bit, but the warming made it so that down a little bit deeper in the water, the oxygen pretty much disappeared. And then the surface waters had lower oxygen as well. And so what happened is that there were only a few species that were able to survive. And the species that could survive, they were the ones that were around that warm climate around the equator. They were already used to warmer water that had less oxygen. And so then when the oceans everywhere warmed up, they moved further north and south. And a few of those were able to survive, but most everything else went extinct. Can you imagine 90% of all of the species disappearing?
And that was the climate changed too rapidly for species to evolve and change.
When we say an extinction event, it's a long event to us because it happened over a couple thousand years. But when you're looking at the history of rocks, a couple thousand years is pretty fast.
A blink of an eye.
So the PT extinction event was driven by climate change. But other extinction events, like the one that ended the age of the dinosaurs, happened with different causes. That one was a meteor that hit the Earth and caused quite a bit of climate change and dust to go up in the atmosphere, but it wasn't caused by, volcanoes or anything else. It was external.
Ooh.
Here's another graphic I wanted to show real quick before we go to our quiz questions. So trying to visualize the age of the Earth and just how long geologic time is kind of tricky. This graphic is one of my favorites because it is a spiral. And you can see that our earliest fossils, we have similar fossils for a really long time where you just have these simple marine life. And then all of a sudden in the Cambrian, there's an explosion of diversity. And you have so much more life and life on land too, not just in the ocean. And then one last look at our 5 extinction events. And this one I like too because it's showing you that over time, we're getting more and more species. So the green, as you can think of it as like the number of species. And here we have our big 5 extinction events. And this one here is the end of the dinosaur. And this one here is our PT extinction event, the Great Dying. And you can see that, whoa, our green line almost got knocked down to 0.
Yikes.
That was a huge event.
Now, you told me once, Science Mom, about extinction being caused by oxygen.
That was way, way earlier.
Is it one of those big 5 or is that?
That's even earlier. So
okay.
yeah, there were microbes on Earth that were adapted to a very low oxygen environment, and then some of them figured out how to do photosynthesis, and we're like, woohoo, we can use photosynthesis, and they're producing oxygen. And some of the other bacteria, once the oxygen levels got too high, they were like, oh, the atmosphere's too reactive, I can't handle it.
So that actually poisoned them.
It was bad for them.
So
yes.
not everybody loves oxygen.
Now, there are two cool things I want to point out before we go to and do our review questions. One is that life is really resilient on Earth. Even with these 5 big extinction events, life continued, and you had new animals that developed and grew. And in some sense, you can think of an extinction event as kind of clearing out space and making way for new life to come. So it's certainly bad for the trilobites or the ammonites or the Tyrannosaurus rexes that are around at the time. But in terms of geological time, Earth really is an amazing planet, and it's set up to have life flourish. Now, we're going to go to the notes real quick.
All right, we are on page
73. And here is another way to think about the history of the Earth. If instead of shrinking it down to a millimeter for a day, we can shrink it down so that all of the history fits in 1 year. And this helps us appreciate, too, just how late some of these things happened, especially...
So let's slow down here. So you're saying January 1st
is the Earth...
Start of the Earth. All right.
So the Earth kind of solidifies after being just a molten ball of really hot
Okay, and then the end of the year is over here. That's today.
That's today.
Okay, so you're saying the Earth is first formed, and first cells don't show up until the end of February.
Yes.
Okay. And then as we travel along by March, algae is showing up.
And that's when they started producing oxygen, and some of the other bacteria were like, oh, no.
Gotcha. All right, then we've got bacteria. Ooh, half the year is over, and finally we get to cells that have a nucleus.
Yes. So we're still just really there's land and there is ocean and there are bacteria and single-celled animals living in those environments. Whoa. And the year's half over.
And then all the way to September when we get the first multi-celled organism?
Yes.
Okay. Well, okay. So traveling along, the dinosaurs don't show up until the middle of December?
Not until the middle of December.
Year is almost over at that point.
And the first flowering plants come even later.
Wait a minute. Flowers came after the dinosaurs?
Yes.
That is weird. That is super weird. Okay.
Because the plants that were around when the dinosaurs first evolved or during the Carboniferous, they just had cones or spores. They did not make seeds.
Okay. And then if I'm reading this right, you're saying humans are showing up December 31st, the last day of the year, and also almost at midnight.
Yes.
So on the grand scale of things, that's just the very tippy end of the timeline.
It is. And Emily has a great question. How do we know this? And a lot of it has to do with radiometric dating. And we're going to talk about this on Friday. But there are certain atoms that decay and break apart. And we can measure how long it takes them to decay, how fast. And then we can look at rocks. And based on how many of those atoms we have, we can tell the age of rocks. So that's where a lot of this information comes from. But also the fossils themselves give a clue. Because when we're looking at this timeline and you look at something like a trilobite fossil and you have trilobites, and then no trilobites, that tells you when those rocks were formed. So certain fossils act as kind of like a timestamp. And they help us to piece together. But it is a big puzzle. And there are changes that have happened to our theory about exactly when certain animals lived and when these extinction events happened. New research is happening there all the time.
Super cool.
So real quick review before we have our quiz questions. We focused on a couple main events. The Carboniferous period, where we had incredible rainforests. We had millipedes that were as long as a person, pseudoscorpions that were this long, and dragonflies with wingspans bigger than pigeons.
So this is where the animals lived that became the oil reserves, right?
Yes, this is when our fossil fuels were created. And you really can think of this as the age of insects. Insects were the main species that you had on land. This extinction event happened a little bit after the Carboniferous, but it's the biggest one. and the biggest one we know of, and it was caused by climate change. There were massive volcanic eruptions that put a lot of carbon dioxide and methane into the atmosphere that caused the oceans to warm. And you also had Pangea forming. The continents were coming together to form Pangea, and that reduced the amount of shallow water that you had in the ocean. So big changes caused a huge extinction event. And then the Cretaceous is the period of the dinosaurs. And that Cretaceous period is when we first had flowering plants come on the scene.
That still boggles my mind that flowers are that new.
Yes.
Just assumed there were always flowers as long as there have been plants.
And Maya has a really good question. What would happen if extinctions never happened?
Ooh.
And that is a fascinating question to think about. So if we had never had a mass extinction event, I think that we would probably not have a planet where mammals were some of the dominant species. Like humans, we make a really big impact on the planet. And then other mammals too, they tend to be some of the top predators, things like cheetahs and lions or bears. Well, bears are omnivores, but they're kind of like the biggest and the most powerful in a lot of different ecosystems. But if there had never been an extinction event, I think it's more likely that our dominant animals on Earth would be insects or reptiles, because the insects and reptiles were the main players before those big mass extinctions.
That's kind of a weird thing to even think about.
It
really
is.
Good question, Amaya, and there's no good answer to it.
It is a really good question, and it's one that's kind of hard to guess at. And then another really good question that I saw was, I just lost it.
So Remington was asking if we'd need to have a chainsaw to clip nails on a T-Rex. Probably, yeah.
Probably.
Something pretty serious. It'd have to be fast, because I don't think they'd like that.
Nope, they would not. All right, we will do some other questions in just a minute, but instead, tomorrow is April Fool's Day. And so instead of a Where in the World mystery today, I wanted to share with you one of my favorite April Fool's Day pranks. And if you are going to do April Fool's Day pranks, I hope you will be kind and don't do anything that someone might really not like. But yesterday, I yelled to Math Dad, "Quick, the toilet's smoking, come look." And Math Dad was thinking smoking like there was a chemical reaction and like the toilet was on fire, and he came running in and said, "Oh no, what happened?" And here's what he saw.
Science, Mom.
So that's one of my favorite April Fool's pranks, just because it's funny, and Math Dad, there was no mess. So
that's good. Yeah, you're welcome to do those types of pranks, Science Mom.
So he was very relieved. We want to wish a very happy birthday today to Christopher, who turns 10 tomorrow on April Fool's. Happy birthday, Christopher. And to Jonah from Ottawa, Canada, who turns 11 tomorrow as well. Happy April Fool's birthday, you guys.
Yep, happy birthday.
And now go to itempool.com/sciencemom/live, because we have some questions for you to answer. And then I will answer some more of the questions that our moderators have gathered in from the chat.
All right, so we're going live. Our first question here. Insects were able to grow larger during the Carboniferous period because of what? Is it because the oxygen levels were 75% higher than today? Was it because there were no large predators? Or strong solar radiation caused the mutations? Or insecticides had not yet been invented?
Which of these reasons is the best answer as to why you had such large insects during the Carboniferous, large invertebrates? And Adley had a great question about that giant scorpion that we saw. So if there was a scorpion this big and you saw it and you were afraid of it and ran away and you climbed a tree, would it be able to cut down the tree with its pinchers?
Oh.
And the answer is no. The wood is pretty sturdy and hard, and those pinchers are really for like grabbing prey and helping it eat, so they would not be strong enough to cut down wood. And also, this scorpion had a very small brain relative to its body size, so I don't think it would be able to plan ahead and scheme like that. Because
But thanks, Adley, for giving me something else to dream about, have a nightmare at night. All right. The answer is A. The oxygen levels were 75% higher than today. So like 35% of the atmosphere was oxygen. That's a lot of oxygen. All right. Question number 2. Oh man, which existed first on Earth? Question mark. Was it sharks or flowers or math dad?
One of those answers is definitely not correct.
But no hints as to which one it is.
No hints as to which one. So one of these definitely existed first, way before any of the others. Which do you think it was?
Sharks, flowers, or math dad?
Or was it math dad?
I'm pretty old. We got one category dominating the vote.
So there was a really good question from Mimi Grace. What does Stethacanthes use that little garden-looking thing on its head and back for? And I will say, so the picture that we showed of Stethacanthes,
That was that fish that had
that big
weird
hump on
hump?
its back.
Okay.
Yeah, and it looked green, but that's just an artist's interpretation. We have no idea if it was green or not. But that horn on its back, we don't know what they were for. So there are a couple theories, but really it's a mystery.
Mystery, huh?
Scientists don't know.
All right, I'm going to reveal the answer to the question here. And sharks.
Sharks is correct. Sharks came on the scene way before flowers. So fish and sharks were living in the oceans millions of years before we had the first flowers on land.
I just thought that flowers would be so much more recent. I'm still shocked.
Flowers are super important to us because a lot of the foods that we eat, almost all of the foods we eat, they come from flowering plants that produce seeds.
Yeah, assumed they would have always been with plants. But, all right. Question 3. What was the main cause of the largest mass extinction in Earth's history? A meteor hit the Earth? Increased greenhouse gases caused climate change? Algae produced oxygen? Or the magnetic poles swapped places?
Ooh.
What was the main cause of the largest mass extinction in Earth's history? Ooh, multiple categories getting votes.
And we have a treat on Math Dad's shoulder. Here you go, science puppy. Up here. Go get it.
Oh boy, Science Mom. 3 different categories are super close.
Oh man, they're almost tied.
Oh man. Oh, I think they're just trying to make it suspenseful now. Changing their votes. Oh yeah. All right, I'm gonna call it. They said A, a meteor hit the Earth. And that's incorrect. Option B is correct. That TNP?
The TP extinction event. So, Math Dad, your face. He was like, I did it. I stumped them. This one, do your little victory dance real quick and I will explain. So the largest mass extinction, and remember, there have been several mass extinctions. The largest one was actually not the meteor coming and ending the age of the dinosaurs. The largest one was after the Carboniferous and before the dinosaurs. And it's called the Great Dying, or the PT extinction event. And it was caused by changes in the atmosphere, huge volcanic eruptions and large releases of methane that made the atmosphere different and caused there to be massive warming, and that changed the temperatures of the oceans.
Did you hear that, Science Mom? I think I heard tears. They're crying because they're getting crushed by Math Dad.
No, they're not, because they know that this is all part of learning, and
that's true.
Yes. And I think
it is
also
totally okay to get answers wrong.
It is. It's part of learning. Math Dad and I get answers wrong all the time.
We do. We do.
Like recently when we were painting a room in our house and we made mistakes in how we painted it. And then we had a realtor come over and they were like, who did this? And we were like, we did, and we did it wrong. Sorry. All
right, true or false? Spiders lived on Earth at the same time as dinosaurs. So were there spiders around when there were dinosaurs? We didn't actually talk about that one at all.
We didn't. This was one of the questions that I saw in the chat. Someone asked, when were the first spiders? So we're about to find out the answer.
Well, this one's pretty close too.
There was a little bit of a hint though, because
or are you going to give a hint again?
Scorpions are related to spiders. They're in kind of a similar family, and we know when the first scorpions came around.
Oh boy, Science Mom. Oh boy. All right. Closing the poll. True. So that is the case. Spiders go way back.
They do. At the time of dinosaurs, you had spiders, you had insects, you even had small little mammals There were lots of different types of animals that were living at the same time, but the dinosaurs were the dominant, biggest ones.
Nicely done, guys. All right.
Very good job.
And then, which is longer, a geological period or a geological era? Eras versus period. Which one
is longer?
This is kind of a tricky one, but I imagine most adults probably wouldn't know the answer on this either. So, boy, but apparently it's not as evenly split. Most people are selecting one of the two answers. I really didn't expect. I thought this one would be the close one.
You thought you'd stump them with this one?
Yeah, or at least come close to stumping them. I don't know. Maybe they're all getting it wrong.
Nope.
Nope.
Nope. Prepare for your defeat, Math Dad.
An era is longer
correct.
than a period. Nicely done, guys.
Good job. So eras are way longer than periods, and then within periods we even have smaller divisions. But some of our understanding of that can change as new research comes up. But it's important to understand just that concept of geological time being so long.
And imagine how long you think it is, and then just realize it's longer than that. You would have to go back so far to watch these events. And when you see like fossils that end up that were in the ocean that end up on top of a mountain, you've just got to realize that must have taken a long time for things like that to occur.
Real quick, Noah has a good question. Did spiders get really big like the scorpions? I do not believe that you had spiders during the Carboniferous forest. I think they came a little bit later, at least not big ones. I have not seen any fossils of big spiders.
Thanks for something else for me to have nightmares about.
And quick reminder, we do not have a new dance. We do not have a new dance today. But quick reminder that on Friday, things are going to be a little bit different because we, should we tell them?
We're going to
our big news?
Pre-record.
Does that mean we should not tell them our big news?
Oh, go ahead. Tell them big news.
We are putting our house up for sale, and we are going to be moving, which is very exciting and slightly terrifying. So we need to be out of our house on Friday, and we are pre-recording our lesson. So the lesson will be pre-recorded and it will premiere. That means it will be a public video. So if you don't find the email with the link, you just come to the YouTube channel at 10 o'clock. It'll be public and we'll be in the chat so we can talk to you in the chat, but it's not going to be a live stream. So that's a difference for this coming Friday.
Yep. Actually, a really fun day. We've got some fun projects involved for Friday. So
we do. So it's the candy rock cycle and Skittle carbon dating. So there are some fun hands-on activities that will show you instructions for how to do. And if you have a little bit of candy ready, then you can try them out yourself.
All right.
And we will talk more about the move next week because we are out of time and have got to go. Work hard, grow smart, and we will see you on Friday.